we're going to do some example problems for linear transformations. So for our first problem, we have this linear transformation given by these three equations: y1 equals x2 minus x3, y2 equals x1 times x3, and y3 equals x1 minus x2. And we're asked to find if this transformation is linear or not. So for a transformation to be linear, it needs to have the following properties. The transformation of two vectors, or if you put two vectors into a transformation, then out that should be equal to the sum of the individual transformations of the vectors. And if you multiply a vector by a constant and put it into your transformation, it should be equal to the transformation of that vector times the constant. So we can check this property right here and see if it holds for this transformation. We can have one input vector called v1, and we'll call that a, b, c. And if we just do t of v1, we get, for our first component, it should be our second input component minus the third, so e minus c. And then y2, our second output, is our first component times our third component, so ac. And actually, I should be, yeah, this is fine. For our third output, we should have the first input minus the second input, so a minus b. Okay, so now if we do the transformation of k times v1, we should get k v1 is ka, kb, and kc. So we should get kb minus kc, ka times kc, and ka minus kb. So this ends up being k times b minus c, k times kac, only one k comes out, and then k times a minus b. And if we just scale the transformation of v1 by k, we see that the two aren't equal because of the extra k here. So since this doesn't respect this property here, this is not linear. Okay, our second transformation is so now we can again construct two vectors, v1. Well, this time we're doing two. Last time we only did one. v1 is abc, v2 is def. And let's go ahead and verify this property here. So if we do k times v1, we get 2, and maybe writing this as a linear transformation will make more sense. So, and this x with an arrow over it just means x1, x2, x3. So t of kv1 is 2kb 3k c and ka. And if we factor out k from this, we get 2b, 3c, and a. If we just do t of v1, we get 2b, 3c, and a. And if we multiply both sides by k, we see that these two are equal, so scaling by constant works. Now if we do t of v2, we get 2e, 3f, and d. And if we add these two, v1 and v2, we get v1 plus v2 is a plus d, just using matrix addition rules, b plus e, and c plus f. So this turns out to be 2b plus e, 3 c plus f, and a plus d. Which equals 2b, 3c, a plus 2e, 3f, and d, which turns out to be t v1 plus t of v2. So since these are equal to each other, this is a linear transformation. For our next problem, we're given a transformation that has the form t of x equals a matrix A times x, and we're also told that t of 1, 0, 0 equals 7, 11, t of 0, 1, 0 equals 6, 9, and t of 0, 0, 1 equals negative 13, 12, or negative 13, 17. And we're asked to find a. So the shortcut way of doing this is that these all correspond to columns of A. First column will correspond to wherever the output is for 1, 0, 0, so 7, 11. Second column will correspond to whatever the output of 0, 1, 0 is, so 6, 9. And third column will correspond to negative 13, 7. So that's the shortcut way of doing it, but if you want to see the details, we know that A has an input of 3, so since the matrix multiplication works where the number of rows of the thing you're multiplying by needs to equal the number of columns of the thing being multiplied, you know that we have 3 columns here. And since we're getting out, our output is 2 columns, or 2 rows, we know that A should also have 2 rows. So we know A has 6 entries. We don't know what they are, so we'll just use A, B, C, D, E, F for them. And then pretty much you do this. You know that T of 1, 0, 0 is A times 1, 0, 0, so A, B, C, D, E, F times 1, 0, 0. When you multiply that out, you get AD, and we're told that equals 7, 11. So we know A is 7, D is 11, and you keep on doing that, and you'll find B, E, C, and F. So yeah, that is our answer.